so we haven't discussed ARIMA. So next week we will discuss forecasting, forecast of ARIMA model, and then after that we discuss ARIMA. When the series is not stationary, then we have to apply differencing, and then we use ARIMA, atau regressive integrated moving average. And then after that, the next topic is seasonal ARIMA. Seasonal ARIMA. So when we have seasonal variation, and we use seasonal ARMA or seasonal ARIMA. So it depends on whether it is stationary or not. And then the last topic on the regression with ARIMA errors. This one I mentioned before. So because previously when we do regression, we just ignore the problems of autocorrelation. So if those who have learned econometry before, you learn. I mean, if you have regression, there are a number of ways you can use to remedy the problems of autocorrelation. So this is another possible way to remedy autocorrelation by adding ARMA errors in the model. Okay, the one we discussed the last topic. So this one, you need to find your own data. So you found group 4 or 5 members, but I think 5 better. It's up to you, either 4 or 5 member per group, and then you need to have sufficient data. And then please use the reduced data, do not use the all data. Find the reduced data, at least until 2034 data. You have monthly data, for example, or quarterly data until 2024. Okay. So this one just how the mark will be given. So you need to make sure. So in your report you cover everything in terms of the selection of data, and then you explain step by step how you select model, how you estimate parameters, how you produce forecast, and how you relate forecast accuracy, and then in the end you make comparison all the 3 methods. Regression, so ETS, this one using exponential method, I think you just use ETS, this one ETS. So exponential modeling method, you just use ETS, and not the conventional one, use ETS. And then ARIMA includes seasonal ARIMA as well. So normally we just call it ARIMA, but it also covers seasonal ARIMA. And then the last one you get your ARIMA errors. So you have about, so now week 8, week 7, week 8, about 7 weeks, okay, almost 7 weeks. But you have enough manpower, 4 or 5 members, they just dedicate, dedicate what each of you need to do. Alright, what else? I want to remind you as well, now we already in week 7, week 8 already. So in week 10 you will have your class test, right? So please prepare for now. So the class test will cover everything that we discussed in the first lecture until lecture 9 next week. Forecasting of ARMA model. So for the test, you just need to use EViews, no need to use R. Or you want to use R as well? Yeah, EViews. So you get EViews. So you have to make sure that you know how to use. Please make sure you know how to use EViews. Okay, so last week, what we discussed last week, recall. So just a quick, what we call that, revision what we discussed last week. Not last week, 2 weeks ago. Okay, the previous lecture, so we discussed, I introduced you to what we call as autoregressive model, moving average model, as well as mixed model, autoregressive moving average. So we discussed the characteristic of the theoretical ACF autocorrelation function, as well as theoretical partial auto correction function for different process, MA1, MA2, MA3, and so on, MAQ, as well as AR1, AR2, AR3, ARP. Okay, so that's how we obtain this one. That's how we obtain this table. Okay, this table on how to identify potential pure auto-recursive model, pure moving average. So this one again, so this one for pure AR or pure MA model only. Not for mixed model. For mixed model, although you can try to have combination, but remember that this what we have here is actually derived based on for the case of pure MA and pure AR. Okay, not for mixed model. For mixed model, you want to identify model, normally what we do, you just estimate a number of models. Let's say you decide maximum order of P and Q 6, for example, then you estimate all the 36 or 35 model. And then you compare AIC or SIC, select the one that has smallest value. Okay. So that's one that can be done. So for ARIMA model also we also can do just like ETS now. We also can select model automatically based on AIC or SIC. Okay, but for now we just like ETS, we also can identify model based on graph. We look at the graph and then we decide what is the best model. Okay, so for ARIMA model the same. So ARIMA model we also can look at the ACF and PCF and then propose model based on ACF. The sample ACF, sample PCF. Okay, alternatively you also can select model. Okay, using criteria like AIC and SIC, we select model that has smallest value. So that one we have EViews and R both have allow us to select model automatically by choosing model that has smallest based on certain criteria. You decide you set criteria whether AIC or SIC or other criteria. Okay. So this one. So recall we discussed before, there are steps you need to follow. Okay, so what you need to do, basically this one is based on what we call Box-Jenkins framework. So this one, so what you need to do first, you need to prepare data, transform data. So I mentioned before again. So this one, if the data you check the variance, it has what we call it not a constant, not stable variance. You can use log instead of ordinary data. Use log information. But remember, when you use log transform values of series, when you produce forecast, you produce forecast for log of the series. So you need to convert that value of forecasted value to the original using anti-log. Okay, anti-log. So if you use it easy because it allows us to choose whether you want to use forecast for the original values or forecast for the anti-log. Okay, for the original values. So different data to obtain stationary if this is not stationary. So the next two lectures after test Okay, so we discuss how to identify whether this is stationary or not. If not stationary, then you have to make it stationary through differencing. Okay. And then you select model, either you look at the AIC or SIC, or you just select model based on AIC or SIC Okay, either one. So either you estimate ACF them and propose potential model, not necessarily one, you can propose more than one. Okay, and then you can, and then you estimate Okay, estimate model. So again, if you have more than one model, then you can select model using suitable criteria like AIC or SIC. And then after that, you have to check not only for the SCF based on residual, but as I explained before, you also need to check for the invertibility as well as stationarity. Okay, if moving average model and A model, we check for the invertibility. If auto-recursive pure AR model, for mixed model, you have to check both. If there is an A component, then you have to check for the invertibility. Remember what the meaning of invertible? Invertible means that the model has equivalent auto-recursive representation. Okay, and A moving average representation has equivalent representation so that it is invertible. So you have to check invertible or not. If not invertible, then you should not use it. You should not use that model. And if there is a R autoregressive component in the model, you have to check whether it is stationary or not. Okay, so it is easy to check by looking at the ARMA structure. So I mean the inverse of the MA roots as well as inverse of the R root, whether they are within unit circle or outside unit circle. We need it to be within, inverse of the root to be inside unit circle. And then after that you check whether so you check ACF of the residuals. Okay, to make sure residual is just like in FOG model, we need the residual to be random, meaning that it must be serially uncorrelated. Each value of the residual, because residual is estimate for the error, so we need our assumption error is random, is individually independent each other. So there is no any influence of any value of error on the other errors. So you need to be we need to be serially uncorrelated. So you use ACF, and then you also perform environmental tests to check residual whether the residual can be considered as white noise. If not white noise, then you can use that model. You have to consider other model. You have to find other model. So let's say FAR2 and then try other model. So you have to check and use. So you have to explore other model, AR1 for example, or AR3, and see whether you are able to get a model that satisfies the assumption that requires residual to be white noise. And then if you pass all the tests, then you can, or diagnostic, and then you can use that model to produce forecast. Okay, so next week we discuss how to produce forecast. So this one I already mentioned before, the one are given by the diagram. So in terms of identification, so given a variety of ARIMA model, it can be difficult to decide which model is most appropriate for a given set of data. The following step outline an approach to this problem. So produce plot of the data, identify any unusual observation, decide if the information is necessary to stabilize the variant. So either use plot or you can use plot like not stable. If necessary, transform the data to achieve stationarity as well, using or through differencing. Okay, so what is differencing? That one I will explain later when we discuss the topic. So when stationarity has been achieved, examine the autocorrelation to see if any pattern remains. A R or MA model may be revealed. The pattern of autocorrelation and partial autocorrelation will indicate a possible model. So if there is no significant autocorrelation after lag Q, then the MEQ model may be appropriate. If there is no significant partial autocorrelation after lag P, and ARP model may be appropriate. If there is no clear MA or AR model suggested, a mixture model may be necessary, but mixture model are much harder to identify. I mentioned before, you cannot, basically we do not identify ARMA model by looking at the hologram. Okay, but we identify model by comparing the criteria. So model selection criteria like AIC or SIC. So there may have been more than one possible model identified, and we need a method to determine which of them is preferred. One possible model selection method is to compare the AIC, case information criterion. So this is just one what we call that variant of AIC, but not all software use the same formula to calculate. Okay, you compare it, you estimate model using EViews, and then you estimate the same model using R, then you get different value of AIC because R and EViews use different version of formula to calculate. But the way that we use that formula, or the way that we use that value, or that AIC or SIC value is still the same. So meaning that we estimate number of model, and then we just compare AIC, and then we select the model that has smallest. But you have to compare models estimated using the same software. You cannot estimate, let's say, half of the model using use, half of the model using R, and then you compare. You don't do that, because the way that the two software calculate AIC as IC different. So you cannot, if you want to compare value of IC, compare models, all models that estimated using the same software. Yes, if you just use Invius. If you use R, just use R and compare AIC and SIC. Okay. So it's just the one formula, but I'm not sure which one is used. So I did not investigate. So basically, we just use. I did not investigate the software R and use what formula as a formula. But what important is we know how to use it. Okay, how to use it, how to make comparison in this decision. So n number of terms estimated in the model, you can choose the value of P and Q for RMA PQ model by minimizing the AIC that's given by that formula. So it involves the likelihood as well as number of parameters. Okay, just like AJSTR square, you remember what we did before? AJSTR square, it analyzes additional number of parameters. If you include more variables, then AJSTR square is used to see whether additional variables is really helpful to improve model or not. So similar that is not. So we have it analyze the number of parameters. So the more terms we have at AR, so only if the model, the additional terms of AR and A able to improve the model substantially, then it will give a better AIC. Otherwise it produce higher AIC because it penalizes for additional number of parameters. We don't want to have, remember before, number of parameters it influence number of degree of freedom. So higher degree of freedom, less reliable our estimate. Not higher, smaller degree of freedom. Smaller degree of freedom, less reliable our estimate. So there are several modifications to the AIC that are also used for model selection, including the SIC, swatch information criterion. So based on the AIC or SIC, we may wish to choose a simpler model either for simplicity or for the sake of getting a better model fit. This is because the AIC and SIC are calculated based on the likelihood, that is representing the accuracy of prediction and penalty term for the number of parameters to be estimated. So AIC and SIC do not necessarily share the same model. Sometimes they suggest different model because the way that it penalize additional number of parameters different. Okay, so sometimes we get different suggestion if we use AIC and SIC. So you have to decide which one you want to use. So estimate the parameters. The method of least squares can be used to estimate parameters for ARIMA model. However, models involving N and A components, there is unfortunately no simple formula that can be applied to obtain the estimate as there is in regression. Remember that one before? Regression you can easily estimate because there is formula. Those who learn applied geometry before, you know the formula that if we regress y against other x, then we can easily use formula. You express that in geometry form, then there is a formula that we can use to get estimate parameters, the slope, the intercept, and so on. But when it involves the error term, so we no longer able to use that kind of formula. So instead we need to use the iteration. So instead, an iterative method must be used. A preliminary estimate is chosen and a computer program refines the estimate iteratively until the sum of square error is minimized. Another method which is frequently used is maximum likelihood. The likelihood of a set of data is denoted by L is proportional to the probability of obtaining data given the model. So there are different what we call ways of the estimation that can be used. So the method of maximum likelihood, find the values of the parameters which maximize the likelihood. Like this square estimate, this estimate must be found iteratively when it involves the n terms in the model. Computer program for fitting ARIMA model will automatically find appropriate initial estimate of the parameters and then successively refine them until the optimal value of parameters are found using either least square or maximum likelihood criterion. So just like optimization that we did before for the case of exponential smoothing. What I remember, we use Excel solver. Basically, it is similar concept of optimization. So we assign initial values and then we run optimization to find the set of variable that give us smallest. Smallest depends on this one whether we want to have smallest or highest, what we call the objective function. And then diagnostic checking, although our selected model may appear to be the best among those models considered, it is also necessary to do diagnostic checking to verify that the model is adequate. This is done by the residual to see if any pattern remains unencountered. So based on the Box-Jenkins step that I showed you just now, it does not suggest us to check the invertibility as well as stationarity, but basically, it's good to check that one as well. Okay. So this one, by looking at the residual, we hope to find no significant autocorrelation and no significant partial autocorrelation. So the Jukebox heuristic can also be applied to residual as an additional test of which one already described before. So you can check individual value of ECF autocorrelation, or you just perform joint house testing. So if the test had been significant, then the model would have been inadequate. In this case, we would go back and consider the other model, not necessarily ARMA model or ARMA. The pattern of significant spike in the ACF or residual may suggest how the model can be improved. For example, significant spike at the seasonal lag suggests adding a seasonal component to the user model. So that's possible. So you check, you see that lag 4 in quarterly data, so perhaps you can add that seasonal AR or MA in the model. Any new model will need their parameters estimated and their AIC values computed and compared with the model. Usually the model with the smallest AIC will have residual which resemble white noise, but it's not always what we call that happen like that. So occasionally it might be necessary to adopt a model with not quite the smallest AIC value but with better behaved residual. Okay, most of the time, the one that has smallest AIC or SIC, that model specify the assumption of the residual to be white noise, but not necessarily done. Okay, sometimes. So even though it has smallest AIC, but the residual is not white noise, then you can use it. You cannot use the model. You have to use other. You have to consider an alternative model. ARMA model with non-zero mean. So recall that equation for ARMA model is given by this. Okay, the above equation represent any ARMA model with zero mean. So let's say it fluctuates, the series just fluctuate around zero, then you use this model. Okay, use the equation YT. However, if the mean of the series fluctuates around non-zero mean, not around zero but non-zero mean, then you should use this one. So instead of YT, use YT minus mu, so that you have a constant in the model. Okay. So if YT is replaced by YT minus mu, where mu is the mean of the Y values, then a constant term C would ultimately appear on the right hand side of the equation. So you have constant. So normally how to decide this one? So basically you inspect the graph to see. First you have to make sure the series stationary first. Okay, that's the first step. Make sure the series stationary first, and then you inspect graph to see whether the mean of the series 0 or non-zero. So if non-zero, then it is what we call that. You need to use this one. Okay, meaning that you have a constant in the model. Okay, otherwise just zero. This one. But if you cannot decide based on graph, then when you estimate, you just include C in the model. If you use, for example, and see whether that C is significant or not. If significant, you retain that C lah. If not significant, you can take out that C. But remember in this equation, C represents constant. Okay, constant is not necessarily equal to mu, but C in use, it gives us estimate for mu. Remember, when we put C in use, that C give us estimate for this one, mu, for the mean, not for the C, not for the constant. C in abuse give us estimate for mean. Okay, so to get the constant is not necessarily equal to this one. I mean, later you get example in our model, for example, for a certain model, if you get to, I think lab session 6, I think I provide this one. Example of model, let's say AR2 model, AR2. So let's say the series has non-zero mean, then you have to use this one instead of YT, you have to use YT minus mu. So mu multiply, okay, and then you express the equation like this. So your constant is one, constant. So the constant is not mean, but the constant is mean bracket 1 minus P1 minus P2. Okay. For pure NA model, the constant exactly equal to mean. But for autoregressive, it's not like that. For autoregressive, the constant is something like this. It depends on the model. Okay. But remember, if you put C in abuse, that C doesn't give us the whole thing here. Okay. C in abuse, it does not give us the whole constant. It just gives us estimate for this only, mu. Okay, C in abuse just give us estimate for mu. So if you want to write equation, either you write like this or you calculate and then you put the value like this for the constant. Okay, later we do example. Alright, so lecture 8 this one on the application part. So we use the same method I used before, the Canadian employment series. So in previous, I think lecture 6, okay, where has been the choreogram for the Canadian employment series, and we saw the sample autocorrelation reduce or then slowly, and the sample partial autocorrelation just cut off just the opposite of what is expected for a moving average. So you recall that if we have the data here, this one, lecture 8. So this data. So recall that previously we have the series, and we have the series, like this one. So we inspect choreogram. So you go to view. So assuming that the series is stationary, okay, the first step actually you should check first this is stationary or not. But because we haven't discussed that topic, so we discuss that after your midterm test. So midterm test we not cover that one, so just cover after forecasting. Okay. So you go to view choreogram. So choreogram represent diagram of ACF and PCF. So level original series. Level means original series. So recall that what we produced before. So we have the sample ACF, sample PCF. So if you see this one, this has what we can consider as decreasing value or exponential decay, and then this one cut off by at 1, 2 cut off to 0. Okay, so meaning that it is consistent to AR, not MA, because MA, the one that decreasing exponential decay, this one cut off to 0, this one. Remember? This one, this table, this table. This one. So ACF if the one that we see just now, ACF exponential decay, and then PACS spike at like 1 and 2, and then cut off to 0. So basically, we can propose the R2 R2. based on graph. Okay, based on graphical inspection, ACF, we suggest, based on sample ACF. This is not a true one. Remember what we have here is not true ACF. It's just like mu and x bar. Remember, what we have here is sample, not the population one. Sample ACF, sample BCF. So we just use this in order to make statement or decision or statement about a true value for population. So we check lah. We check whether significant. We check whether the significance of this value. Okay, so this one increasing, this one spike at 1 and 2 and then cut off to 0. So basically, by looking at this table, it is consistent to theoretical ACF and PCF for AR2. Okay, so we not for the case of MA lah. So it says here that opposite of what is expected for moving average, because it is more consistent to the autoregressive instead of moving average. Then the diagram indicates that a finite order moving average process would not provide a good approximation to employment dynamic. Okay, so it doesn't seem to be moving average. So instead of, it's more to AR. So nevertheless, nothing stops. So we can try for this example. We will explore all model and see the comparison. Although based on graph, it suggests autoregressive and autoregressive order 2 AR2. So but this one we try to just to make comparison. So we just estimate and the model as well, and then we compare. So nevertheless, nothing stops us from fitting moving average models. So let's us fit them and use EIC and SIC to guide model selection. To do this, estimate an AQ model. So let's say again, so this one you have to decide earlier whether up to which order you want to put the limit. Okay, so whether you just want up to order 4, but normally we use 5 or 6 lah. Okay, so normally my suggestion do not go beyond 6, so maximum maybe 6. So 4, 5 or 6. Okay, but it depends later on. If you have quarterly data, you cannot go more than 3, because later we discuss that one. If for the case of quarterly data, and like 4, displacement 4 is already seasonal component. Okay, because quarterly data have 4 observation, S equal to 4. So we need to include seasonal NA, seasonal AR as well. So for quarterly data, normally just up to 3. For monthly data, you can go up to 6. Okay, for up to 6 maximum order. Okay, so we don't want to have too many parameters. So normally we just limit. Okay, so to do this estimate, let's say we decide we don't want to have more than 4 the order. Okay. So we estimate MA1, MA2, MA3, MA4. Okay, just now we expect the graph. We see the graph of the citizen is one. So again, assuming that it is stationary. So if you get to the graph in terms of the mean, it has 0 mean or non-zero mean. It's not around 0, so non-zero mean. It's not around 0. It is very likely that when you estimate a model, C is going to be significant. Okay, C is going to be, because I mentioned before, C gives us an estimate of the mean. Okay, the mean of the series. That's why you need to make sure series stationary. Do not use the data that has trend. So we need to have the stable mean. Stable mean. So this one, estimate a model. Quick estimate equation. So how to estimate a model? Your variables, the name of variable depends on what name of variable you use. So if here we use CAEMP. Okay, so just now we decide whether to include C or not by looking at graph. but you're not sure, let's say graph is not clear enough for you to decide, then you can just put simple and see whether it is significant or not. Okay, if it's not significant, you can remove. So let's say you put C, MA1 So this is how we estimate MA1. So the range of data that we use until the last quarter, say quarterly data, the last quarter of 19. So this one we use up for, it's actually quarterly data. Okay, you might have to we just follow let. But again, in later on, when you consider seasonal RNA, then maybe a better idea that you just set limit up to 3 because it's quarterly data. So at like 4 is already seasonal. Seasonal MA, seasonal AR. Because now we haven't discarded one. It should be okay. So this one, okay. So C is significant, you can retain the C. MA1, so this one, MA. So this is our model. So we have theta, MA1, so we have theta. Theta that represent, this one represent estimate of theta. Okay, and then this one I mentioned before, estimate of the, because epsilon T is a Wagner process, we mean 0 variance sigma square. So this one I estimate for the sigma square. So what you need to check? You need to check because this is moving average, so you have to check because there is MA terms. So you have to check whether it's invertible or not. So basically you're already able to know, but you can't hear because inverse are the MA roots. Okay. MA1 there is only one root. So inverse of that root negative 0.93, so it is inside the circle. Okay, but you also can check this one. You also can check aroma structure. You go to view aroma structure, and then either you check graph or table. So graph. So inside, inverse inside the circle, or you check the table. Table is C, it tells you. I mean. It tells you whether it is invertible or not. Okay. But don't rely on this one. So let's say you do exam, for example, there is no information given like this output. Then you have to decide based on the value of the roots, inverse of the root. Then you should be able to know how to know whether it's invertible or not. So invertible means what? Invertible means that this model MA1 has an equivalent autoregressive representation. Okay. And then after that you have to check residual. Remember, residual must be white noise. Okay, otherwise it has autocorrelation problem. Just like econometric model, it has autocorrelation problem, meaning that it will have some impact or implication on the estimate, which will make the estimate to be not reliable. So this one, view residual diagnostic choreogram Q statistic. Okay. So this the residual white noise or not? I mean residual serial corrected or not, or serial uncorrected. This one you discuss before. How to know, how to make conclusion. So based on this you inspect one by one. Of course, basically based on this autocorrelation. So autocorrelation, we need it to be 95% of them to be inside the interval, or you perform the joint harvesting. The joint harvesting, 128 observation. So you take square root of that. So basically there are a number of different suggestions. Some suggest you perform the test, do not add light of replacement, no more than the square root of sample size. But you read there is in the textbook, the online textbook, there has a different suggestion. Okay, if you have seasonal data, it suggests you to at least perform at lag equal to S. That one I will share the data. So this one for now, let's say we just use that rules. We just perform the test. Do not go beyond square root of this sample size. Okay. So 11 for example. So we have 11 something. So let's say at lag 11. So the Q statistic here. Then you also p-value, you have p-value given here, p-value for the test. So recall this one, we perform the test at lag 11, it means what? We are testing the null hypothesis, which suggests that the true autocorrelation at lag 1 between yt and yt minus 1 and lag 2, yt and yt minus 2 up to lag 11. Yt and yt minus 11 all are equal to 0. Okay. And then the p-value, alternative at least one of them not equal to 0. So p-value 0 less than 0.05, normally we perform the test at 5% significant level. So at 5% significant level, we reject. Okay, understand? So p-value is one. As usual, for any test, when p-value less than our significant level at 5%, let's say 5%, p-value less than 0.05, we reject the null hypothesis and then we accept alternative. So in this case, alternative says what? Alternative hypothesis says that at least one of the autocorrelation between from replacement 1 up to 11, at least one of them not equal to 0. So not equal to 0 means that it's not white noise, because there are some influence of the previous error or residual on the current residual. Okay. So this model is not adequate. Say it's not adequate. It's not because residual is not white noise. So recall that. Where is that? So recall that this one, we are here now. So is there the residual white noise? So the answer is no. So you have to go back to this one and then adjust other model. Okay. But this one because this is not, we select model not based on ACF, we just try. Okay. But just now if you select model based on the choreograph of the series, it's just R2, not MA. Okay, but we just want to see. So we want the purpose of discussion. Okay. So that MA1 is not adequate, so you cannot use that model. You should not use that model MA1. Okay, so if how about MA2? To estimate MA2, you can just re-estimate and just add MA2 as well. Okay, so just add additional term MA2. So we have, so if you want to estimate MA2, not only put MA2, some student, not from my class, I think I also noticed that many students sometimes. So they didn't take class, so when they estimate model MA2, they just put MA2 without MA1. So you have to put MA1 as well. Because why? Because theoretical MA2, it is 5 and 1 and 2. So you have to put both lah. MA1, MA2, not only MA2, put MA1 and MA2. Okay. So even though you look at the ACF is not significant. Later we have an example. So if you want to estimate that model, you have to include everything. So okay. So again, because we have NA terms, we have to check the invertibility. So looking at here, we know that it is invertible. There are two roots, but maybe that's the number. You want to make it easier, then you check this one graph. Check the graph. So both inside, inverse of the MA root both inside, so it is invertible. And then check what? Check residual chorogram of the Q statistic. Just now 11 also same, so it is not an adequate model, so it's not good model because residual not white noise. Because p value, so we need p value to be greater than 0.05. Okay, this one less than 0.05. MA3, add one more. So, invertibility, check invertibility, graph, all inside, okay, invertible. How about residuals? Same, also not adequate. So it's not adequate, so we have to other model. One other model. So MA4. MA4 in terms of invertibility. So this one MA4. So we have, remember this one C for pure MA, the constant is exactly equal to the C, equal to the mean. But for autogressive is not. Autogressive constant is not necessarily equal to. It's not equal to mean. But C in ABUS give us estimate for mean. Okay. So remember this one C. This C is not estimate for the whole constant. For AR, for NA okay, for NA yes, it's true. But for the case of AR model autoregressive, that C in ABUS give us estimate for this, not the whole thing, not the whole constant. Okay. So we have theta 1, theta 2, theta 3, theta 4. Invertibility, Arma structure, graph, okay, invertible, residuals. 11. Still the same, huh? Still the same. So all MA1 up to MA4 all are not adequate model. So residual not white noise. So both the AIC, you compare AIC and SIC. So just now, if you estimate the model, you have the AIC and the SIC here. This one AIC, SIC. Okay, so if you want to compare based on SIC, you can get this one, this value. So both AIC and SIC suggest the MA4 is best. However, the Beam-Wilson statistic indicates the MA4 model failed to account for all the serial correction employment in employment. The Beam-Wilson represent what? Remember now, we done before. For those who have already done. The Beam-Wilson represent first order autocorrelation. but just now we check choreogram, because choreogram we are able to see not only first order, second order as well, third order as well. Because we have leg 1, leg 2, leg 3, leg 4. The new one just like leg 1 lah. First order, YT and YT minus 1. Okay. But we check program allow us to see more beyond first order. Not only first order, the new only first order. But the new 1.67 is not that bad. Sometimes close to already, but this one still. Because this one is at first order, but when we check the higher order just now, so they are higher order autocorrelation. Okay. So residual plot can indicate a neglected cycle and impression confirmed by the choreogram. So if you check after you estimate, if you go to actual fitted residual graph, you are able to see that. So the residual. So we need the residual to be random. Random means that random means that you cannot see the pattern, something like this. So if you have something like this, the next keep increasing, something like this. So meaning the previous value has some influence to the next value. So that there is no, it's not random. Okay, now let's consider alternative approximations such as autoregression. So we do the same. We are autoregressive order 1, 2, 3, 4. So now estimate autoregressive model. So now instead of MA, use AR1. Either you go to quick, you estimate other model, so can you go to quick, estimate equation. So the name harus ini CAEMP C AR1. Instead of MA, AR, use AR. You go to quick, estimate equation, identify the model. Okay. You can make equation 1. So if you want to save the idea estimate model, you can just save. If you don't want to save, you just delete it. So this one is significant as well. So the new version very low, 1.06. So this one we have C estimate of the mu for the mean. This one phi 1 estimate for the phi. And then inverse of AR, this one determines what? It determines the stationarity. Okay. So you go to ARMA structure, graph. So it is inside the circle. So this one is quite close, very close. Okay, so but you can see this is slightly inside. But to get, you can check the value you got ARMA structure, check table. So this ARMA model is stationary. So this one, this is stationary, not invertible, but stationary because AR roots. So we have AR polynomial. We don't have MA. We only have AR. So AR determines the stationarity. MA determines invertibility. Okay. So almost close to 1 and 0.9. Because we want it to be equal to 1. So 1 is already on unit scale. Okay. Residuals. Residual, so you go to view, residual, diagnostic, choreogram, Q statistic. So again 11, this one also the same. R1 also, it's not good model, residual not white noise, so you have to consider other model. This one cannot be used. Cannot. How about AR2? Estimate, add one more, AR2. Okay, so we have estimate for the mean, phi1, phi2. Inverse AR root, both inside. Okay, Raman structure, both inside. Inverse of AR root, both inside. We need all, not only one. So we need all. If any one of them on, we need circle or outside. Then this means it's not stationary. Estimate the process is not stationary. So this one okay. Estimate the process is stationary and then residual. Statistic program Q statistic 11. This one okay. MA2 AR2. So this one residual behave as what we want. So residual can be considered as white noise, okay? Because p value for the test greater than 0.05. So you check prof, actually better. So this one looks more random lah. Okay. How about AR3? You can just add one more. So AR3, you check inverse of AR root, all inside, and then it is liquid or not? Residual, liquid. This one also can be used. Sebagai model lah. AR4, one more. So this one also inside, all. It has 4 roots, all inverse, all 4 inverse of the root inside. You need circle. So you check inside. Residual also okay. So only AR1, AR2 okay, AR3 okay, AR4 okay. So out of the 3, which one? So now you have 3 that you can use. Which one you can select based on EIC. Okay. You can compare and then choose EIC or SIC. Which one has more value? Okay. If you want to explore for mixed model as well, then you can also you can try. So this one, if for the case of pure AR, both AIC and SIC suggest that the AR2 is best. The estimation result looks good and the residual looks like white noise. The residual choreograph support that conclusions. You check the residual just now. Okay, we have already checked that one. Now, finally, consider mixed model, ARMA PQ model as a mean or ARMA PQ model with P and Q less than or equal to 4. And then this one again, you have to, if you have to compare, then you have to take note, you have to record the value of EIC and SIC. Okay, so ARMA 11. If let's say ARMA 11, how? MA1 over AR1 MA1. Okay, ARMA 11. So ARMA PQ 11, ARMA 11. So this one, you notice that we have 2 inverse of AR root as well as inverse of MA root. So you have to check both. You have to check whether the model is invertible as well as stationary or not. So you go to view, ARMA structure. So we have both this one quite close to skull on the unit skull, but you can check the table. So this one, but I think it's still quite clear that it is inside. So you go to view table, armor structure table. It is stationary as well as invertible. Okay. Now you can extend, you can add more. Let's say ARMA 22. So I will not do everything here. So you want to do later at home, you can estimate. So let's say just do few examples. So ARMA, how about ARMA 22? So you have to put AR 2. MA. So ARMA 22. So you have to both. Okay, so we have this. So as usual, you check our structure to see whether it's invertible as well as stationary or not. Yes, so all inside, so it is invertible as well as stationary. Estimated process, residual. So 11. So it is adequate. So residual 4. So you can use the model. Okay. So if you do the same, right now, right, if let's say for other model, let's say ARMA 3, just add. Or ARMA, okay, another example, ARMA 3, 2. So AR 3. This is ARMA 3, 2. Okay, so just add one more, and then okay. So you get the estimate of the V1, V2, V3, theta 1, theta 2, and then this one estimate for the mean for new, and then you check armor structure all inside. So it is invertible as well as stationary. Estimated process, residual. It is okay, greater than 0.5, so residual why not? So model, you can use that model for the next step. Okay, for application part to reduce forecast. So if you compare, okay, so you estimate all, and then you compare, and then you can see that the one that has smallest AIC is AR2. AR2, and then SIC you compare, you produce the same. AR2 has smallest SIC as well. Okay, it has more AIC, has smallest value as well. So both AIC and SIC select AR2, and then that is consistent with the current expression. If we consider a model selection strategy involving examination of not just the AIC and SIC, but also autocorrelation, partial autocorrelation, we are led to AR2. So recall that the series before, this one series, if you inspect ACF hologram, the series one, the series, you inspect hologram, it suggests it is consistent to AR2, because this one decreasing, exponential decay, this one spike like 1, like 2, cut out to 0, so AR2. So whether you identify model based on hologram, or you just estimate all model, then you identify which one has smallest AIC or SIC, you get the same result. So AR2 perform the best, is the best model for us to propose. Okay, because it has smallest AIC as well as SIC. So we have one thing to discuss in lab session 6. It only has 3 questions. So you want us to have 30-minute breaks, or you just want to discuss this one and go home early? So we start this one first, and then I will let you go. We finish our lecture early lah, maybe at 8 or before 8. Okay, lab session 6. We only have this one, we only have 3 questions. So, given the first data set, so consider the following time series data which is given in the EViews file. Before that, I forgot that one. The EView assignment, so that one, because one of you asked about if you use EView, you get different model. That's why I mentioned just use R, because the question instruction asks you to use R. So remember that R and EViews use different way to set initial values. I mentioned before. That's why different software EViews and R can set different model. Okay, because it use first because the way that is select initial values different. Second, because the way it perform optimization also perhaps different as well. The way that we conduct all the optimization. So that's why it's possible that we get different suggested models. Okay. So you just use R to identify model, but again later on for the discussion part explain because you see that based on graph it's supposed to be like this, but because the automatic model selection is select model based on AIC. So AIC just looking at the value of the error, they calculate AIC. It does not take into account whether it has strength, whether it has signal, it just AIC only. So AIC is not necessarily just according to the pattern of the series. So you can put that in discussion part. If let's say you identify model based on looking at the graph, whether you are able to get good vector focus or not, you can try and you explore. Okay, so this one, so we have the data. By looking at the graph, it seems it has non-zero mean, so meaning that it's very likely that if you include C, if when you estimate you include C, it's going to be significant, because this one non-zero. So the question asks, if you want to apply ARMA model to describe the series, should you include a constant in the model? So the answer is yes, based on graph. By looking at the graph, and then you should include. So you have the data in the spectrum. So this one Q1 data. So again, how to check the series? You just open this one, click this, the series Y, and then you go to view, produce graph, and you can have a look at the graph. Okay, so this one. So you can decide if you think, if you feel that the variance is not constant, maybe better than use log. You can decide you can use log transformation. If you think it's better for you to get a better model. So let's say this one we just use original values, so we do not apply log transformation, so that we will produce forecast of the original values, not for the log series. Okay, so what's the next question? By inspecting the ACF and PCF, suggest the appropriate model to describe the series, write the model in terms of the backward shift operator and without the use of that backward shift operator. So to identify model, assuming that the series is stationary, then you can just go to view and check ACF PCF of the series and program. Sample ACF, sample ACF. Level. Okay. So this one, if you compare this one, it is considered which one? So either if you consider this to be decreasing, then you can propose up to. Okay, but remember before, there is no only one correct model, because we just want to find a model that can use as approximation for that process. So you can consider more than one. So it's okay to have it. There is no only one correct model exists. Okay, you can. They say you see there are two, but I also want to try if the possibility of NA4 as well. Because when I say you set the maximum 6, for example, you just inspect out the first 6 leg, and then if based